Hi, this is Jeff from the Ozark Mountains in Missouri, USA. We're back to our TRS-80 multi-pin plotter here. We've got in our filtered power entry module, our new capacitor. So we'll get those put in. Let's jump right in. Quick note here as I'm editing this video. Just last night I thought of how to fix up the software I wrote for this, and so there's some bonus footage tacked on the end, which is plotting of some different things. So watch the whole thing. Thanks to PCBWay for sponsoring this video. They not only do PCBs and flex PCBs, they also have 3D printing service, injection molding service. They do CNC machining, sheet metal fabrication. They also have a thriving maker community where you can share projects and check out what other people are doing. For your next project, head on over to PCBWay. Alrighty, first a bit of a confession. I goofed when I tested the original capacitor in here, and we'll go through that again. It doesn't say 12 microfarads, it says 12 millifarads. Yeah, so that's about 1200 microfarads. The listed rating on this is 8500. It may be this capacitor's good. When you're 50% over the rated capacitance, that might be okay on some of these older ones. Some of them were, plus 80, minus 20% sort of thing. It can also be an indication of internal electrical leakage in the capacitor across the dielectric. So since there's electrical leakage, there's current going from plate to plate, it takes longer for the capacitor to charge up. And it looks like when you measure the capacitance that it is a higher capacitance. So, since I already goofed up and I already have a new part on the way, or new part here actually, we'll go ahead and install the new part. This is a good brand, and you can see how much smaller it is. The downside is that these big axial caps are impossible to find anymore in a lot of values, so we'll go with the radial cap and we'll extend one of the leads. So we're going to go ahead and get these parts installed. And then we'll look at what we're going to do about pins. Okay, since we have an idea of how this guy comes apart this time, let's see if we can make it a bit faster process. We'll back out those grub screws. Okay, now we got to our board. And we were able to loosen these two screws and rotate the board around last time. And I think this time we can not take it as far apart since we have a better idea what we're doing. Power entry module is right down here where my finger's pointing, and the capacitor's there. And this is going to be taking this out, putting this guy in. So I'll go ahead and do that. I'll leave the camera running for part of the time and speed it up so you guys can see it. So we start out by taking out the temporary power entry module. I wanted to mount the new power entry module from the outside instead of the inside because it's a little longer, but it didn't quite fit in the hole. So I had to knock a pin out of the hinge point, which was kind of a pain in the butt. Took several tools and several minutes to figure out how to do that. Then I was able to slip it in there, put some screws in from the outside, and eventually wire it up from the inside, which was hard to see. So now it's time to install the old cap, remove the abomination that I put in there before. Wound up with something like this. It's a little bit ugly, I think, but it does work. Okay, we got it back together. I'm going to go ahead and turn the power switch on. We'll see if we can drive it around manually. Manual. Okay, so everything's still okay. Now, one other problem I noticed, besides parts falling off of this thing, is that this is crooked. If you look in here, you can definitely see it. It's a couple millimeters higher on this side than this side. This is the pin holder. And this plastic bit here is just taped onto, I don't know if you can see the sticky of the tape in there, but this is just taped to that. And it has come loose over the years. So I'm not exactly sure what to do about it, but I can fix this later. I think that will have to be carefully peeled off of there and stuck back down with some new tape. But then, you know, you've got pin alignment to worry about, that type of thing. Okay, so what about our pins? Well, the original pins look like this. It's a plastic body. There's a little cap on the end, which isn't too hard to flip off. Inside the body here is some floof that was originally rolled up inside this plastic sleeve like this. Kind of reminds me of a cigarette butt. I've never been a smoker, but you know, everybody's seen a cigarette butt. This falls apart pretty readily. And inside this tube like this, the tip of the pin here runs all the way up inside and presses into the bottom of this guy. So the ink that's trapped in this fuzzy stuff here transfers to this nib down to the tip. This is that business end, and I don't know if you can tell that it's got stuff stuck on here, which I think is probably the tip of the nib that was supposed to stick up in there. I tried refilling a black pin, and you can see this is all my chicken scratch trying to get it to right. It does just a little bit. It doesn't soak down ink fast enough. I think that nib just breaks off when you try to pull out the fluff. So maybe if you put, you know, half a cc of distilled water in there to kind of flush out the solid parts of the ink that are in there, let that dry, and then put maybe half or 3/4 of a cc of ink in there, it might do it. But I kind of think with these old pins, and they don't seal up real well, in the end here, it's actually open to the inside. It's some type of vent. So I don't think these are a viable thing to try to re-ink once they've completely dried out. If they haven't dried out, you can probably just add some more ink by pulling that cap off. So, a friend from the Tandy Assembly, he was there a couple years ago and did some wonderful plots. He sent me a 3D model that a friend of his son did for a pin holder. I couldn't tell what type of pin insert this was made for, but I made a drawing from the STL so I could take some measurements on it. I designed my own to use the Pilot G2 pin inserts because that's what my friend recommended. I'll pop up a couple of his plots right here that he just did, which I thought were pretty cool. He actually did the second one and gave it to me at Tandy Assembly in 2023. I've got it around here somewhere. So I made my own, and the pin slipped in there, but it was held just by friction. So since this is going up and down as it's drawing, eventually it's going to push it back up in there. And I thought, well, I could thread the end, slit it, and then screw a nut on here like this, which will squeeze these fingers together and hold the pin. Of course, this nut is way bigger than it needs to be. There's more threads than it needed to be. So that distilled down into this. And really what I need to do is take an actual tap and tap out, clean up the inside of these threads, because these are 3D printed and they're not super exact. But that tightens down there well enough that this pin is not going to move inside here. And of course, it's a new pin. It does right. This has a 0.38 millimeter tip I've got some others with 0.5 millimeter tips. They have like 0.7 and 1 millimeter tips as well. So I think these are a pretty good choice. They're available everywhere and it's a good brand. So now we can try some drawing. Okay, so here we've got a pin in there. It just, oh, this is hard to do left-handed. There, like that. In the rack here, they pop in like so. So this would come over and pop this into an empty slot, pick up one in this slot. So we can put this guy on manual. Tell it to drop the pin down and drive it around. It's like the world's worst Etch-a-Sketch. And once you put it in pin down mode, it'll pop up after so long so you're not bleeding into the paper. Now watch this. I did diagonal. Woohoo! So anyhow, we can draw. We've got a way to hold a pin, and since we don't have any height restrictions, these Pilot G2 pin inserts work really well. The pin holders are doing okay. And now we need to get it interfaced to a computer. I asked in the last video what you would like to see it interfaced to. The most popular choice was a modern computer, and then the choices varied between, you know, like a TRS-80 4P and, you know, something else. So I think we'll do the modern computer first. I found some software that should be able to talk to this guy over the serial port, and we'll see how that works. Bit of an update on the pin holders. I ran out of the original filament I used, and I thought, oh, I'll print them in this nice looking blue. And it turns out this stuff was super brittle. So I put the blue away. I have this silky beigey looking filament that I've had around for a while, so I thought I'd try that. I printed off one, and it worked fine. I printed a bunch more at one time overnight, and the ones I printed overnight were super weak as well. It seems skipping from holder to holder as it's doing the layers, give the layers time enough to cool, that it made that joint really weak. So then I printed them one at a time, and these are nice and strong. You might be able to hear the 3D printer now. I added a chamfer to the nut and to the top of the threads here to make that easier to start threading on there. I added a 1/4 millimeter chamfer at all these edges right here, so it's a little easier to slip into the pin holder. And you might just be able to see how this edge is a little messed up here. These are printed standing like this, so there's some filler material in here. I expanded the filler material out about 1/2 inch all the way around this, so it'll protect that edge a little more, keep it from cooling down too much and doing that little warpy-dorpy thing. Now, this is just PLA. It's not the best material for this. I ordered some PETG, which is a little more flexible, a little tougher. It's not quite as hard or brittle as PLA. So I'll try these again in PETG and see if that makes for a better holder. And I'll get the file for this uploaded online after I try that. So, and then I'll update the description down below. One thing I noticed as I was testing this, it sounded a little crunchy or rough in some places. And I know the manual said don't lubricate these rails, but I took some silicone lubricant, sprayed it on a Q-tip, and run it over the rails. So it dries completely dry. It leaves a dry film on there of silicone. And I actually used 4 Q-tips, and they all come out kind of looking like this. So there's quite a bit of dirt on those rails that you just could not wipe off with a dry cloth. And it did sound a little quieter after that treatment. Now I want to demonstrate 3 different ways of plotting the test image. It's actually built into the ROM on this. So I just turned it on. I'm going to press the reset button back here on the back edge. put it in manual mode, and then hit left and right at the same time. You notice I'm starting with no pin in the pin holder. Try that again. There we go. I did adjust the tension, which is the set screw right here. Adjusted that half a turn, put a little more pressure on these pins, and they work pretty good now. Remember, I found the little slug that fell out of there. There was also a spring. The spring goes in first and then the slug, and that's what that presses on. So it adds more spring pressure down on the pin when it's not being lifted. So here we're going to plot the same thing from the PC. I tried a program called InkCut, which can generate some DMPL, but it won't talk to this plotter. This Radio Shack plotter is like a hybrid between DMPL Mode 1 and Mode 2. It uses the Mode 1 startup sequence here, semicolon, colon, and then H, which is go to home position. The Mode 2 startup sequence looks more like this. And Mode 2 also uses a different handshaking than Mode 1. Mode 1 uses X on, X off, which would be super simple, and you could use any, terminal program basically. But Mode 2 uses a maximum send buffer length of 256 bytes, including a carriage return as an end of line. And then the plotter will return a carriage return when it's ready for up to 256 more bytes. So this plotter is the Mode 1 startup like this, and Mode 2 buffer, or vice versa. I forget which is which, but it's a hybrid. So I had to write my own program to send that, and we'll just load that test demo. And I added this here, which just shows you the number of times each pin is called. Pin 0 should always be called once. That is the put whatever pin you have away. And so that way you're always starting out with no pin in the holder. We'll go ahead and connect to it and say send. So it'll show you the lines as it's sending them, and you'll see every once in a while it will pause as it's waiting for a carriage return from the plotter. And you see that line there that said S17? That is a special type of line, S14 line graphs, that tells it to plot the text that follows. It's a modal command, and it expects that everything is going to be on that same line, which ends with an underscore. If not, you have to insert a special character to tell it that the line continues after the carriage return. If you don't, it locks up. It doesn't know what's going on. I tried to make this program to be able to condense files like this to fewer lines and take files generated by other programs that are too long, greater than 256 characters, and divide them into more lines. But that modal business with the S command for text plotting throws it all off. And see the P0 and Z, that's the end of the program. But the plotter has that all buffered. So here we have our plotter in a TRS-80 Model 100. I thought this was a pretty good between say like the Model 4P and a pocket computer. And it was kind of fun trying to do it on this. The downside to this is it only has one serial port. I wanted to try to read the file off the backpack so I could plot a larger file, but I couldn't do that. Okay, here we have our Model 100 fired up. I'm going to run this basic program, which I called Cinder. Now we'll type in the name of the test file. And this will send it in a very similar manner as the PC over, waiting for carriage returns back from the plotter. Yeah, you see this slow down here? This is because I'm printing the code to the screen, which takes a long time. I'll show you that. Dumping the code to the screen like that as it's plotting out takes a while. And it holds things up. But it's great for debugging. But you notice it plots just the same. And the Model 100 is done sending the code out. I don't know if you can see there where it says P0Z. There it's printing that dashed line with the inflection points. Well, how about that? We got our plotter plotting. We found some pins that'll work. Thanks to Tim, who suggested these pins and shared his knowledge about Radio Shack plotters. You'll notice that the plotting area here is asymmetric because this is the end that the pin holder's on. If that pin holder wasn't there, it would go over to like there. But you might just be able to make out there that it does a pretty good job plotting. I'm happy with that. Maybe tweak the pin pressure a little more, that type of thing. The nice thing with these Pilot G2 pins is they're available in 0.38 millimeters, 0.5 millimeters, 0.7 millimeters, and 1 millimeter. So you can try a different variety of widths of pins and get different effects and things like that. That'll be a lot of fun to try out. Now, before I can do any of the fancy, really long plots like Tim does, I'll need to sort out my sending program on the PC and think of a different way to do the same thing from a vintage computer. Like a Model 100 with the disk video interface, you could pull the program off of a floppy disk. That would work. That would be one way to do it. There were banked memory extensions for the Model 100. You might be able to use that and try to access some of the RAM on the other banks. I don't know if that would work or not, but it might. But then you'd have to get it there, and that would be kind of a pain. And if you use like the Model 4P, that would work. You've got a disk drive. Pocket computer, still you run into the problem you don't have a lot of memory there, or you can't access the serial port and storage solution at the same time to get the data from. So further work is really on the software to produce the files for this and to manipulate them, and a little more tweaking on the pin holders, trying out the different materials and things like that. Look in the file description down below. I'll put all this information and links to the programs and everything as it becomes available. And this is a very well-built plotter, so if you happen to have a chance to get one and it interests you, yeah, go ahead and do it. It's a lot of fun. Any questions or comments? Well, I would love to hear from you. Leave them in that comment section down below. Thanks to everyone who helps support the Hey Birt channel. It is greatly appreciated. Happy New Year 2025, and until next time, bye. Okay, update. Right as I was editing the video, I was watching a rerun of Numbers last night, and it occurred to me how to properly package the code into the right-sized segments. So the first thing I'm going to plot says TRS-80. I did that with ink cut. I had to scale it by 0.2 on both X and Y to fit. This plotter has a resolution of 5/1000ths of an inch per step, so I'm guessing ink cut is set up for 1/1000th resolution. Don't know. And then we'll do a USA map, which you can probably see under here, which is just a single color, and it draws the USA and all the states and a dot for the state capitals. So here goes the TRS-80, and the rest of this will just be ASMR, and you can see the size of the code now being sent. It's about 40 characters in length each time.